Hi guys, here we have video tutorial number 3, and I'm doing this mainly to help your homework number 2. And last class we discussed the kinematic equations and we applied them along the y direction. So this video is based on the vertical motion, and if you remember, here we took up as our positive direction along the y direction, and taking this as our reference direction, we took the corresponding acceleration unless stated otherwise. I just put this G to represent that gravity, but you don't have to use it. It's simply acceleration, negative 9.8 meter per second square. And I'm going to put that in the box. So I'm not going to, go over the equations because the video actually gets, too long. But at this point, you guys are familiar with all these equations. So I'm going to directly discuss a problem, and this problem can be found under week number 2, the second PowerPoint presentation, and we actually started doing the problems there, but we didn't really get much time to discuss many. And to help you guys with the homework number 2, I decided to discuss this one problem. Now let's read this. A pitcher tosses a baseball up along a y-axis, and the initial speed of the ball is 12 meters per second. So it is always important to draw a little diagram, and I always mark my y-axis. So here goes the y-axis, and this is the 0 point. I believe you can see that in the little window. In a minute, I'm going to switch to the main window. And the initial speed, here I have the initial speed given to me as 12 meter per second. So this is 12 meter per second. And the question asks, how long does the ball take to reach the maximum height? So I just mark a point and I call this the maximum height. And we all know at the maximum, final velocity equals to 0. If it is not 0, then you can't actually call that point as the maximum, right? So I'm going to go back to the the recording. But before we go there, let's see what we are supposed to find. First part, how long does the ball take to reach the maximum height? And the second part asks, what is the maximum height? So basically, we are looking for time t in the first part and delta y in the second part. Now, don't get confused with delta y and delta x. They both actually stand for the same idea, which is the displacement. And the third part is little tricky. So I'm going to come back to this after we discuss the first two parts. Now here we go. As you know, we always set up the table. So let me set up the table first. And I mark up as my positive direction. So the initial velocity, I already know that, 12 meters per second. Final velocity at the top, I know that, 0 meter per second. Unless stated otherwise, I said A equals to negative 9.8. That also is known. And we don't know T, and we don't have delta Y either. Delta Y is the height to the maximum point, right? So these two things are not known. So the first part asked us to find T. So part A, find T. So pause the video and decide what equation that you need to use to find T. Okay, so here we have the 3 equations. We have V final, V initial, and A. So I believe you paused the video and decided what equation to use. And the equation that you need is V final equals V initial plus AT. So V final is 0, V initial is 12, A is negative 9.8. So I directly put that negative out here. And then the time t is t. And I take this 12 to the other side. This is for the students who are having some issues with the algebra, negative 9.8. And then I isolate the time t, and you divide both sides by negative 9.8. So negative 9.8, negative 9.8 cancels out. And you can take your calculators out and find what 12 divided by 9.8 is. And you will find t equals to 1.22 and the unit, don't forget, it's in seconds. So the time that you need for the ball to reach, or for the ball to reach the maximum is 1.22 seconds. Now that we have the time, we can move on to the second part of the question. And the second part asked how far is this point is. So in the scale, if I mark this, this is my delta y, right? So going up, the ball reaches the maximum and then it returns. So basically this is what happens, right? Okay, so to find delta y, again, you can choose one equation from the equation sheet. There you have two equations in this case. One is the second equation and the other is the third equation. So I am going to use the third equation, where you have V final square equals V initial square plus 2a delta y. V final is 0, and I'm very happy when I see that 0 anywhere when we have a 0 velocity. That's a reason to be happy. And then V initial is 12. Don't forget to square that. And then here you have 2 times. Don't forget the negative sign. Negative 9.8 times delta y. So 12 square, bring it to this side. And if you use the calculator, you will find out that it is 144. Since you bring it to this side, you add a negative sign there. And the negative sign over here comes to the front. And there you have 2 times 9.8 times delta y. Now to isolate delta y, let's divide both sides by negative 2 times 9.8. And you will get this side delta y. And the other side, you will end up with an answer 7.34 meters. So the height from the starting point to the maximum point is 7.34 in meters. So meter is the SI unit. Don't forget that. Now I'm going to take you back to, oops, you can't see that, right? So here we go. The final answer. Yeah, you can check what I did. I mean, of course, you can pause the video and go over the material, go over what I wrote. And then I'm going to share the screen again and look at the third part of the question. Third part asks, how long does the ball take to reach a point? Actually, it should be 5 meters above from its release point. You can't see that 5 because of this picture. Let me go back and fix that. There you go. So you have, how long does the ball take to reach a point? 5 meters from its release point. And I am going to stop share again, and then I am going to discuss this a little bit further, okay? So when you are dealing with the second part, you got to be very careful, because the displacement we discussed in the first class, displacement is the distance between the original point and the final point, right? So if I draw this diagram, here you have the y-axis. And the y-axis, if I mark the scale, like here you have 0, 1, 2, and 3, 4, 5. I have to extend the line, and 6 here, and then 7 here, and then the 7.34 is somewhere over here. And that line is the maximum point, 7.34 in meters. So the ball is actually going up and comes to the maximum point. And then when it is going up, it passes this 5 meter location, right? It passes this 5 meter location. And when the ball is coming down, again, it passes that 5 meter location. So basically, during this trip, the ball passes the 5 meter displacement twice. As a result, we are expecting 2 different times for this part of the problem. Now I am going to set up the table again, and at this point I have the delta y. So I still take up as my positive direction. Initial velocity did not change. It is still 12 meters per second. And final velocity, and at this point, final velocity is not the maximum velocity. Final velocity is the velocity at this point, and we don't have that. We don't know that. So I'm just gonna put a question mark there. And then you have the acceleration. Unless stated otherwise, it is negative 9.8 meter per second square. And delta y, of course, we now know it as 5 meters because the problem has given it to us. And the time t, we don't know. Now, if you look back at the equation, pause the video and look at the equation again, you will see that the best equation to use to find t is the second equation. So you have delta y, v naught or v initial times t plus 1/2 a t square. Now delta y from the table, it is 5. Initial velocity is 12. And we don't know what time t is. And there you have 1/2. And a is negative 9.8. And then you got t square. Now if I simplify this a tiny little bit, there you have 12 times t here. And then negative 9.8 divided by 2 is 4.9 and t square. So here you have a quadratic term of t and then a linear term of t. And there you have no t at all. So what I am going to do is I am going to rearrange this equation. I add 4.9 t square to this side and I add 4.9 t square to the other side. And that gives me 4.9 t square. And then I subtract 12t from this side and I subtract 12t from the other side. And then the 5 is already there. And on this side, we end up with a 0. Now, since I am recording this and I want to make this video shorter, I didn't write everything I told. I was talking about. And then I would like you to follow everything that I said and do that and get to this equation. So here is a quadratic equation, and I'm sure that you have seen the quadratic equations, I believe in first time in the middle school and then second time in high school. So this has the form ax square plus bx plus c equals to 0. That's the form of this equation. So if you compare, a appears as 4.9, b appears as negative 12, and c appears as 5. So the students who are using TI-89, TI-84, they actually can directly feed this equation into their calculators and get the solutions. But for other students, here's what you want to know. T equals, because I am looking at this equation, t is the variable there, minus b plus or minus square root b square minus 4ac divided by 2 times a. And this is what is called as the solution for any quadratic equation. So we have to substitute for b, a, and c. And you will get t equals minus 12 plus or minus and b square minus 12 square minus 4. A is 4.9. I hope I have enough space. And there you have 5. And then divide it by 2 times a. A is 4.9. So clearly, when you look at the plus sign separately, you get one solution. Minus sign separately, you get the second solution. And what I am going to do is I am going to take the plus sign first and write this equation. And I call the solution as T1. So negative times negative is positive. So there you have 12. And I only consider the positive sign. And then inside negative 12 square is 144. and negative 4 times 4.9 times 5, and that you can actually use a calculator and do it. I'm just going to multiply 4 and 5. There you have a 20. 20 times 4.9, and then divide this whole thing by 2 times 4.9. And then the second solution, I am choosing the negative sign here. And there you have it, 12 minus square root 144 minus 20, 4.9, nothing happens in the, like the square root, and then 2 times 4.9. So one equation, one solution, actually this solution, the top solution should get a value above 1.22, and then the second solution over here, down here, will get a solution below 1.22. So this is the task for you guys, to complete this problem and bring it to the class on the next time we meet. Okay, so I'm not going to redo this problem. This is a video. You can go back and forth, or pausing the video and going over it again and again and understand what's given here and what is discussed here. And I expect everyone to complete this part and bring it to the class the next time we meet. All right, so you can find this under the third week announcements on Blackboard.